Hello and welcome to episode 11 of Evidence for Belief, a series which examines evidence for the existence of God. In this session, we're going to examine some amazing aspects of both our sun and our moon as further evidence of an intelligent designer of our universe. And we're going to see how both these celestial bodies play a role in making our planet uniquely habitable. So, let's start with the sun. Our sun is a huge fusion reactor, 1.4 million kilometres in diameter, which is about 109 times the diameter of the Earth. In terms of mass, the sun is 330,000 times the mass of the Earth. In terms of the mass of the entire solar system, the sun comprises 99.86% of the solar system's entire mass. In other words, the sun is big, and it's also very hot. 5 million degrees Kelvin in its corona, that's its outer layer, and 15 million degrees Kelvin at its core. But the important point for our consideration is that our sun is just the right kind of star, a type G yellow dwarf main sequence star. It's the right size, the right temperature, the right spectral class, the right mass, and at the right stage of its life. And all of that simply means that it emits life-permitting heat and light, while its harmful radiation is relatively mild compared to most other stars in the universe. But only about 6% of stars in the observable universe are this relatively safe yellow dwarf star. For example, type K dwarf stars, which make up 13% of the stars in the observable universe, in other words, they are twice as common as our star, emit 25 times more harmful radiation than our sun. And type M dwarf stars, which make up 73% of the stars in the universe, so they are effectively almost 13 times more common than ours, emit deadly radiation that is 400 times more powerful than our own sun. The remainder of the stars in the universe are much larger than our sun. They are called either giants or supergiants. For example, the supergiant star Canis Majoris, which by the way means big dog, which I think is quite a humorous name for a star. Anyway, Canis Majoris is the largest star we've detected so far. At least it is at the time of this recording. It is 3 billion times, that's billion, not million, the volume of our sun. In this image of Canis Majoris, our sun is so small by comparison that it can't even be shown. It's less than a pixel at this magnification. In fact, Canis Majoris is so large that it could fit 2,000 of our entire solar systems inside it. If our planet was in orbit around a supergiant like Canis Majoris, the star's gravity would be so huge that we would have to be orbiting so far from it that our planet would be a frozen ice block. But fortunately for us, we orbit the perfect sun, a type G yellow dwarf star, a relatively rare star percentage-wise. And as a double lottery win, we orbit our perfect star at the perfect distance for life to flourish. We orbit our sun at the optimal life-permitting distance in what is referred to as the circumstellar habitable zone, or the Goldilocks zone, meaning that it is just right for biological life. A little closer and all water would evaporate and we would be a red-hot barren rock. A little further away and we would be a frozen planet. The Earth's magnetic field is also precisely the right strength. It allows the warmth and light of the sun to reach our planet, but shields us from the majority of the harmful radiation that would destroy life if it reached the surface. But that's not the end of our lottery win in the galactic habitability stakes. The location of our whole solar system within the Milky Way is also remarkably ideal. If our solar system were closer to the galactic core, the huge amount of radiation in that region of the galaxy would render life as we know it impossible. This is an actual image from the James Webb Telescope of the galactic core, the centre of our Milky Way galaxy. It's so densely packed with stars that it's filled with deadly radiation. If our solar system was located there, even though our own star is relatively safe, the ambient radiation of that entire region would strip our atmosphere away and burn our planet to a crisp. Thankfully, the location of our solar system on the outer edge of a spiral arm of the Milky Way galaxy keeps us at a safe distance from the maelstrom of deadly radiation at the galactic core. Propitiously, it also places us in an ideal position to observe the universe. If our solar system was embedded more deeply in the densely populated galactic core, all we would see when we looked up into the night sky would be a thick, impenetrable carpet of stars. Our location, however, on the outer edge of the galaxy, allows us to not only observe the shape and the nature of our own galaxy from a wonderful vantage point, side on, and this is an image of that, but also it enables us to look away from our own galaxy in the opposite direction. It enables us to observe billions of other galaxies in the rest of the universe, like this one, which is a photo of the Andromeda galaxy. It's as if our planet and our whole solar system was deliberately placed in the perfect position to not only keep us safe, but also to enable us to discover the universe for ourselves. So, that's the Sun and our place in orbit around it. Now let's turn our attention to the Moon. We have an extremely large moon for the size of our planet. Our moon is about 28% of the size of the Earth. And that is huge. No other moon-to-planet ratio comes even close to that. There are actually 294 moons in orbit around the planets of our solar system. Yes, there are that many. Jupiter alone has 95 moons. And the largest moon-to-planet ratio outside of our own is one of Saturn's moons, Titan, which is 4.4% the size of its parent planet. Now, this is an image of the moon Titan in orbit around Saturn, taken from the Hubble Space Telescope, and you can see how small Titan is in comparison to Saturn, just 4.4% of the size of the planet. And as I've said, that's the largest moon-to-planet ratio of all the other moons in the solar system. The average of all the moons is actually less than 1% the size of the parent planet. So our moon, at 28% of the size of Earth, is absolutely massive. It's unprecedented anywhere in the visible universe. Now, at this point, you might be thinking, well, that's a little bit interesting, but so what? Well, as a matter of fact, there's a very big so what. Because you see, if our moon wasn't as big as it is, and as close to our planet as it is, biological life would almost certainly not be possible on Earth. You see, the moon plays a huge part in making our planet habitable. Firstly, it circulates nutrients around the planet through its tidal effect. These tides also help to circulate warm water from the tropics, which keeps our northern and southern latitudes warmer and able to support life. Its tidal and gravitational forces also assist in moving our tectonic plates and circulating magma beneath the crust, which helps to bring up heat from the core of the planet to stabilise our temperature and keep us warm. It also stabilises the axial tilt of our planet and keeps us from experiencing more extreme and drastic seasonal changes in temperature. In other words, it stops our planet from developing a severe wobble. Our large moon also acts as a shield that protects us from meteor impacts. Its gravity has captured many large meteors whose impact craters can be seen with telescopes, and which would have been catastrophic for life on Earth if they had impacted our planet. The moon is also one of the main driving forces behind our protective magnetic shield. The moon's gravitational pull, as it orbits the Earth, drives the magma in the Earth's outer core to keep circulating around the solid inner core. This generates a powerful magnetic field which pushes far out into space and acts as a shield to deflect the harmful gamma radiation that the sun is constantly hurling towards us. Without this magnetic field, all biological life on our planet would perish from lethal radiation, and our planet's atmosphere would be completely stripped away. And without an atmosphere, our liquid water would boil away into space, leaving the Earth a hot, dry lump of lifeless rock. So you see, the moon plays a huge role in sustaining and protecting life on our planet. In fact, without it, there would be no life on Earth. But all these wonderful things that the moon does for us are only possible because the moon is so big in terms of its size ratio to the Earth. And as I've already explained, this size ratio is unique in all the known universe. Nothing comes even close. Scientists remain perplexed about how such a relatively small planet ended up with such a big moon. There are three theories. There's the capture theory, that the moon was gravitationally captured by Earth as it passed by. There's the fission theory, that it was formed alongside the Earth at the same time. And there's the accretion theory, that it was blasted off the Earth by a huge impact. But increasingly, all three of these theories have actually fallen into scientific disrepute. A recent article on the website Evolution News, for example, states this: the moon's position and composition have so far baffled efforts to propose an unguided sequence of events that might have formed it. Now, the key word there is unguided. Essentially, that quote is saying that scientists cannot figure out how our comparatively large moon could have come into existence via natural processes. Of course, there is one other possibility, isn't there? Intelligent design. That our very large moon was put there by an all-powerful creator, placed in a perfect orbit at the perfect size to protect our planet and sustain life. But we haven't got to the end of the extraordinary story of the moon, because there's one more amazing fact that we need to understand. It involves both the sun and the moon, and I'm referring to the stunning phenomena of solar eclipses. A solar eclipse occurs when the moon passes directly in front of the sun, momentarily eclipsing it, perfectly and exactly covering the sun. Now, these solar eclipses have enabled scientists to study the sun's corona, its outer atmosphere, in a way that would otherwise be impossible. When the moon perfectly blocks out the main body of the sun, scientists are finally and only then able to see and study the sun's outer atmosphere. These solar eclipses have led to some startling scientific discoveries regarding the nature of the sun and the properties of light, as scientists have been able to observe the refraction of light around the sun. In fact, it's through these observations of solar eclipses that scientists have made many important discoveries about the nature of our universe. For example, during an eclipse, we are able to glimpse stars that are behind the sun, as the sun's gravity bends the light from those stars around itself, making them visible to us. By observing the ability of gravity to bend light in this way, scientists were able to confirm Einstein's general theory of relativity. Now, once again, you may be thinking, well, that's a little bit interesting, but again, so what? Well, what makes solar eclipses so special is how precisely the position and size of the Earth, Moon and Sun need to be in order for an eclipse to even be possible. You see, what is extraordinary is that when viewed from the perspective of Earth, the Moon appears to be exactly the same size as the Sun, so that when it passes in front of the Sun, it exactly covers the Sun, while leaving the Sun's outer atmosphere visible. And so for about 2 minutes during an eclipse, the moon covers the intensely bright photosphere of the sun, enabling us to observe its thin, faint chromosphere and the spectacular corona with its dramatic prominences. And all of this is only possible because of an extraordinary coincidence of ratios. You see, the moon is 400 times smaller than the sun in diameter, but coincidentally, it is also 400 times closer to the Earth. Now, of course, this diagram that you're seeing is not drawn to scale, but you get the idea. The ratio of the sizes of the moon and the sun is exactly the same ratio as their distances from Earth. Exactly. Which is why they appear to be exactly the same size. Now, this is an extraordinary coincidence, which quite frankly, baffles atheistic scientists. The likelihood of this astronomical arrangement arising by sheer chance is too astonishingly small to be considered possible. Solar eclipses are unique to Earth. From our examination of all the planets and moons in our solar system with their relative sizes and distances from each other and from the Sun, there is nowhere else in the known universe where you can observe a solar eclipse, where a planet's moon appears to be exactly the same size as the Sun and where it periodically covers the Sun exactly. Solar eclipses can only be observed from Earth due to this extraordinary coincidence of the ratio of sizes and distances. It's as if someone deliberately designed our planet and moon and Sun to enable us to conduct scientific investigations and make discoveries about our universe. In 2015, science writer John Horgan wrote in an article in American Scientific, "The more scientists investigate our universe, the more improbable our existence seems. If you define a miracle as an infinitely improbable event, then our existence, you might say, is a miracle. Scientists try in vain to hand-wave our improbability away. My own intuitions keep me from ruling out the possibility of supernatural creation." I agree. Our apparent cosmic lottery win in terms of our Sun and Moon, along with the many other factors which have all aligned to make our existence possible, really do stretch the bounds of believability if we try to explain them as merely the product of blind chance. Let me quote again from the Bible. "For since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made." For more information, you can check out my books, which are available on my website, smartfaith.net, where you can also subscribe to my weekly blog. Thanks for watching episode 11. Please make sure you check out episode 12, Do Aliens Exist? And I think you'll find that one fascinating. In the meantime, have a great day.